Right guys, in this video we're going to look at congruence, specifically congruent triangles. First of all, congruent triangles mean that they are the exact same triangle, so same shape and same size. There's nothing different about them. They might be flipped one way or the other, but they are the exact same triangle. So, looking at our example here, we're told diagram shows two triangles, ABD, which is our top one here, and a bottom one, BCD. Prove the triangle 1 is congruent to triangle 2, basically, okay? So, if it mentions congruent, and we need to prove it, we're going to use one of these four. Side, 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 SSS, which means that if all the sides are the same, then it must be two congruent triangles. The next one is angle, side, angle. So for this to be congruent, we need an angle and an angle that are the same in both triangles, and an enclosed side that is the same too in both. Our next one is RHS, which is we've got a right angle triangle, the hypotenuse is the same in both, and they share another side. If that's the case, then that final side must be the same as well, which would bring us back to SSS again. So there are three of our congruency rules which we're going to look for. The other congruency rule is side, angle, side. So we've got a side that's the same in both triangles, another side that's the same in both triangles, and in between those two sides there's an angle that's the same as well. So they're the four things that we're going to look for. What I would do here is redraw these triangles just so I can see them as two separate triangles. So here's my top triangle, A, D, and B. We've got 42 degrees, and we've got 75 degrees. And the second triangle, excuse my drawing, looks roughly something like this. We've got D, B, and we've got C. And our angles here are 42 degrees, 63 degrees. So the next thing that we could do here is find out what these missing angles are, because we might need these. So angle ADB is equal to, if I add these two together, take them away from 180, I would get 63 degrees. What I do need to include here is the angle rule that I've used, because angles in a triangle add to 180 degrees. And second of all, so we're going to do this next angle over here, just in case we need it, angle BCD. And if I add these two together, take it away from 180, I actually get 75 degrees. And same reason there, all we need to do is just put a few quotation marks in to show that we're repeating that angle rule. Next of all, what we need to do now, actually I'll fill these in just so I can see them. So that's 63 degrees, and this one here is 75 degrees. So we can see actually the angles are the same in both triangles, but there's nothing up here that says if the three angles are the same, then they're congruent, so we can't use that. There is one more bit of information that we do know. We know that BD, whatever BD is in this triangle, it's going to be the same as BD in the other triangle. So the way I'd write that is BD is equal to BD. It is a shared side in both triangles. So I've figured out everything I need to know about the triangles and anything that's in common between the two. The final step now is to try and identify, is there any one of these that I could possibly use? Well, side, 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 I don't know all the sides. I only know that BD is the same in both, so they share one side. Angle, side, angle. If we look at angle, side, angle, I've got 63 degrees here. I've got this shared side, and then I've got 42 degrees, which is the same over here. I've got 63, got the shared side, and I've got the 42 as well. So actually, they match up perfectly. So I could use angle, side, angle to say that they are congruent. So we'll finish it off. ASA therefore triangle ABD is congruent to triangle BCD. So I'm always looking for 3 bits of information, either involving sides or angles, that I can prove that 2 triangles are congruent. But I do at every step as well need to put down any angle rules or any justification that I need to put in, even if it means stating the obvious, like they have a shared side or whatever it may be. So make sure you're familiar with those 4 angle rules, or rules for congruency: side, 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 angle, side, angle, RHS and SAS. So anytime I come on to proving congruent question, I'm using those 4. So let's jot them down again. SSS, because I am trying to prove congruency here. We've got ASA, RHS if it's right angled, and lastly we have got side, angle, side, SAS. So ABCD is a parallelogram. E is the point where the diagonals AD and BC meet. Right, first of all, it's a parallelogram. So what I can fill in here is I can fill in these 2 sides are the same, because opposite sides in a parallelogram are equal. So I'm going to note that down here. AC is equal to BD because opposite sides in a parallelogram are equal. I can say similar with AB. AB is the same as CD. So AB is equal to CD because, and it's the same angle rule, so I don't need to write it out again. Next, we also know that these are parallel lines. So AB is parallel to CD. So what I would have there is, I'll highlight it for you. There are your parallel lines. Like so. And what cuts through them is this transversal, this diagonal line. So what I've got here is, I've got some Z angles. So we can say that this angle here would be the same as this angle up here. So angle ACD, which is this angle down here, sorry, angle ACB I should say, AC is our, sorry, ACE is our triangle, so we're going to use E actually. So it's this angle down here to create our triangle down here. So that is equal to angle, and it's the triangle BDE that we're looking at. So we'll look at angle DBE like so. So those 2 are equal, like we've shown on the diagram, and that is because alternate angles are equal. We do have a few more angles that are going to be the same as well here. We've got a second transversal, this transversal here. So what we can do is just illustrate again here where our Z angles are. So there are my parallel lines again here. And this time it's got this transversal. So what you've got here is you've got this angle up here. There's my Z. That's going to be the same as this angle down here. And again, because of alternate angles. So I'll put a little dot just to show you again. Those two angles are going to be the same. So we justify that down here. Angle, this would be angle AEC. Sorry, this would be, A needs to be in the middle, so it will be angle CAE. Is the same as angle D is our angle here, so that needs to be in the middle of my letters. So we'll go with BDE. And that again is because alternate angles are equal. So I think I've got enough information here to show that they are congruent. So what we'll do is we'll draw out our triangles just so we can see what we've got here. And that is angle A, E, and C. And then we've also got triangle, excuse my drawing again, angle B, E, and D. Fill in what we know. We know that AC is the same as BD, and we've already stated that and said why they're the same. So those two are equal. If you look now, we've got this angle up here at A. That's the same as the angle down here at D. And the angle at C is exactly the same as the angle at B. So if we were to highlight what we've got here, we've got an angle, we've got a side, and we've got an angle. We've got an angle, a side, and an angle. So in this case, we would be using angle side angle ASA. So ASA, therefore triangle ACE is congruent to triangle BDE, as we were looking to prove from here. On the next question, I'd suggest you have a go at it for yourselves, see how you're doing it. But again, note at the very beginning your 4 rules for congruency: SSS, ASA, RHS, and SAS. Any rules you use, no matter how simple they are, whether it's angles in a triangle at 280 degrees, then do make sure that you're noting that down. If you need to split the triangles up, then do so, if it makes it easier for you to see them. So pause the video now. Right, hopefully you had some success with this. So we're told ABCD is a parallelogram. Prove the triangle ABC is congruent. So if it's congruent, we're using one of these 4. Prove this congruent to triangle BCD. So first of all, it's a parallelogram, so let's know anything we know about a parallelogram. I know AC is going to be equal to BD. And that's because opposite sides in parallelogram are equal. And I'll be able to say the exact same about AB and CD. Next, we're asked, prove that the triangle ABC is congruent to triangle BCD. So let's draw a triangle and see what we've got here. We've got ABC, so that would be a diagonal up like so. Again, apologies for my terrible drawing. And we have got triangle BCD, so BCD, perfect. So they're my two triangles like so. Let's redraw them at this stage actually. So this would be A, that's triangle ACB, and here's my triangle this is my triangle B, C and D. Fill in what we already know and we've already stated. We know that these two sides are the same. We know that this side and this side are the same length. And finally, we've got CB and CB. So we can say side BC is equal to BC. These are shared sides in each triangle. We do need to state that they are the same, they are shared. So we can note that, maybe 3 strokes this time, like so. So what we've got now is, we have got an angle, or sorry, a side, and a side, and the same side, side over here. So we're using SSS to prove these two triangles are congruent. SSS, therefore my 3 dots, triangle ABC is congruent with triangle BCD. Hopefully you had some success with that. Thank you for watching the video.